We have studied supernova for centuries. We've mapped their remnants, modeled their physics, built entire careers around their aftermaths. But we had never once caught a star exploding as it actually happened, until the night of April 10, 2024. And what we saw in those first few hours rewrote the rulebook. At 3:21 in the morning, the Atlas survey, for wide-field telescopes sweeping the entire night sky every 48 hours, caught a single point of light brightening dramatically over the previous 5.8 hours. 23.8 million light-years away, in galaxy NGC 3621, a star had just died. An automated alert fired across the global astronomical community. This was supernova SN 2024 GGI. And scientists had only hours before its most critical secrets would be lost forever. Here is the problem. In the first hours after a supernova begins, the explosion's original shape is perfectly preserved. But within hours, ejected material crashes into surrounding gas and dust, warping that pristine geometry forever. Researcher Yang and his team drafted an emergency proposal to the European Southern Observatory in the dead of night. The ESO approved it immediately. The very large telescope in Chile swung toward the target. By the slimmest of margins, they pulled it off. Clean, undistorted data streamed back before the window closed. For the first time ever, they had the true shape of a supernova explosion. The VLT's FIRS-2 instrument, the only one of its kind in the southern hemisphere, measures how light is polarized. A perfectly spherical explosion produces zero polarization. But an asymmetric, football-shaped explosion polarizes light in a very specific pattern. And what the data showed was unmistakable. SN 2024 GGI had a clear, well-defined axis of symmetry. The explosion was shaped like an olive, a prolate ellipsoid, organized and elongated along a single axis. For the first time, we had the actual fingerprint of a supernova at the exact moment of detonation. But here's where it gets complicated. When researchers modeled jet-driven explosions in full 3D, introducing just a 1% wobble into the rotating core, the jets went unstable, twisting, kinking, spiraling like a garden hose on the ground. The explosion never happened. And yet SN 2024 GGI clearly did explode. Which means the chaos itself may be the mechanism, jittering jets depositing energy close to the core, creating hot pressurized bubbles that push the star apart while still preserving that organized, symmetric shape. The answer was hiding inside the instability all along. This is one data point. One explosion. One night. And it already cracked open a mystery that has stood for over 50 years. New observatories coming online will let us catch supernovae within 24 hours of explosion, routinely. Every one we capture brings us closer to understanding how the universe's most violent events actually work. We've been studying the ashes for centuries. Now, we're watching the fire.